Okay, so Junior Roberts here again. We're on part 2 of our logic gate series. In this series, we're going to be looking at logic gates. I've done part 1 earlier. If you wish to check it out, I will put a link in the top of the screen and also in the description below. So let's get started with part 2 of our series. So our learning objectives for this section of our series is to be able to define the NOT gate, to derive the truth table for the NOT gate, and also to formulate a Boolean expression for the NOT gate. So let's go right into it. Okay, so as usual, we have to ask ourselves what exactly is the NOT gate. So the NOT gate is a type of logic gate that accepts a single logical value as its input, and it produces a single logical value as its output. So basically, the NOT gate it takes in a single input and produces a single output. And then we're gonna go further and look at the functionality of the NOT gate. So again, just as a refresher, this is the symbol for the NOT gate. Again, as we can see, it's a triangle with a bubble at the front, and this is its input and this is its output. And as we said before, it takes in a single input. That is why we have one input here, and then it produces a single output. Now, how does the NOT gate work? So the NOT gate is sometimes called an inverter, since it essentially inverts the logical value which is present at its input, and it routes that inverted value to its output. So each logic gate has its own truth table and Boolean expression, and we're going to talk more about the truth table and the Boolean expression for the NOT gate in this video. So we're going to start with the truth table. So let's look at the truth table for the NOT gate. So but before we can go into looking at the truth table for the NOT gate, we have to get an appreciation of what a truth table is. So a truth table is a table which shows the possible inputs and output for a logic gate. So here we have the truth table for the NOT gate, and we have a column labeled as our input and a column labeled as our output. Now, the NOT gate, as we said, it takes in a single logical value, and from our previous video we spoke about the fact that a logical signal can be either high or low, on or off, or 1 or 0, and in our case we're going to be focusing on 1 or 0. Now, since the NOT gate takes in a single input, it can either take in a 1 at an instant, or it can take in a 0, right? So that is why we have our table here with 2 rows for our input. So let's start to fill out the truth table. So as I said before, the NOT gate can take in a 0 or it can take in a 1, right? Now we need to know what will be the output if there's a 0 at the input and if there's a 1 at the input. Now, since the NOT gate is essentially an inverter, whatever value is at the input, it will invert that value and pass it to the output. So when we have a 0 at our input, we will have a 1 at the output, because this 0 gets inverted as it passes through the NOT gate and becomes a 1 at the output. Similarly, if we have a 1 at the input, that value will be inverted and we will get a 0 at our output. So the truth table here basically demonstrates the inversion capability of the NOT gate. So when we have a 0, we get a 1 at the output. When we have a 1 at the input, we get a 0 at the output. So this is our truth table for the NOT gate. It's one of the simpler truth tables to remember, but essentially, if we are able to appreciate the functionality of the logic gate, we can easily derive its truth table. So now let's quickly look at the Boolean expression for the NOT gate. So The NOT gate Boolean expression is given as y equal not x. So what this is saying is that our output y, let's look back at our truth table. So our output was y and our input is x. So when we look at our Boolean expression, we're seeing that our output y is equal to x, and we have a single quotation mark here which indicates not x. So we're saying that our output y is not x. So whatever x is, our output will be not that, or the inversion of that. So if we had our 0 at our input, our output will be not 0, which will be 1. And if we have a 1 at the input, our output will be not 1, which will be 0. So basically, the Boolean expression also helps to give us an idea of the functionality of the logic gate. So let's quickly wrap what we have learned so far together. So what we've learned so far is that the NOT gate, or sometimes called an inverter, is a logic gate that inverts the given input and routes it to the output. A NOT gate takes in one input and produces a single output, right? And the Boolean expression which governs the NOT gate is given as y equals not x. Alright, so again, this was Junior Roberts from realjuniorroberts.com. If you enjoyed this video, please hit the like button. If you have any questions, please post them in the comments below, and I'll do my best to clear up any misconceptions for you. If you think someone else would benefit from this video, please consider sharing so they can get access to the video. Also, if you haven't subscribed as yet, please hit the subscribe and the bell notification so you'll be updated whenever I post new videos like this. Thank you for watching.